Okay guys, we're going to talk now a little about the sculpting methods. As we saw before, the sculpting consists in displays the geometry of the surface. So, by default, sculpting consists basically in that. However, when we are working, we are going to have different needings for our models, and the initial geometry is not going to be enough. So along the process, we are going to need new geometry. And at this point, we are going to see the sculpting methods. We are going to talk about the three main methods that are the available methods in Blender. The first one is the dynamic topology, the second is the voxel remesh, and the third one is the multi-resolution modifier. So let's begin with the first one, that is the dynamic topology. I'm going to make here this movement, this stroke, and as you can see, this is deforming and stretching a lot the geometry. You can see these polygons are very stretched. But if we use the dyntopo, the dynamic topology, what we're going to do is to create new geometry along the sculpting. I'm going to do the same operation to let you see. Here we activated the dynamic topology, click here, press OK, or just press Ctrl D. It says that we can lose some geometry information and press OK. And I will make again the same stroke. When I do it, you can see that in real time it is creating new geometry. So this way we are going to have always a good level of geometry. The resolution of this method could be found here in the detail. If we decrease it, we are going to have more detail, more geometry. We are going to have smaller polygons. And if we increase it, we are going to have some bigger polygons. So this is a method that is very useful to add details without damaging the rest of the mesh. Well, the next one is the voxel remesh tool. I'm going to sculpt here some shapes, something like this. We are going to stretch a little the polygons here, but when we use the voxel remesh, that is with the shortcut Ctrl R, Blender is going to create a new geometry. As you can see, we are getting new geometry in all these new areas. This is how it looks at the beginning, and with Ctrl R, we are going to have this new geometry. So this is another workflow we can use. We can sculpt, and from time to time, we can remesh to keep always a good level of geometry. We can also manipulate here the density. If we decrease the value, we are going to have more geometry and more detail. In addition, with this remesh method, we can also add geometries. We can join them. I will join these two objects with Ctrl J, then go back to sculpt mode, and if we press Ctrl R, it is going to join the both geometries. I will decrease the voxel size, press Ctrl R again, and we can see that it is merging both objects. So this is a practical way to merge two different geometries. There is something we have to take in mind, and that is that the dynamic topology and the voxel remesh are not compatible between them. So if we start sculpting with the dynamic topology, I will make some random shapes here like this, sculpt around, and then if we want to remesh with Ctrl R, it is possible that it doesn't work. Here I have dyntopo activated, and it is going to block the remesh. Uncheck it, and now we have the remesh, but in sometimes it is not going to work. Also, when we do a remesh, we are going to lose much of the geometry we created with the dyntopo. The high levels of details are going to be lost because the remesh is going to put all the polygons in the same size. And the dyntopo instead is going to change the level of detail in some areas. As you can see, we have here some different levels of detail. Here we have more resolution. And well, let's search here for the Dintopo tool here. And this is by default in the detailing in relative detail. That means that the level of detail depends of how close I am from the model. If I am very far, the polygons are going to be bigger. If I am very close, we are going to have more detail. I can also change this to constant detail to create all the polygons with the same size. I'm going to increase the size. And this way we are going to have always the same size of the polygons, the same density. And if I want to have all this geometry with the same size, with the same level of detail, I can press here in Detail Fluid Fill, and it is going to fill all the surface of the geometry with polygons with the same size. Well, I will remove this. I'm going to create a new cube and put a subdivision surface modifier, and I will add 3 subdivisions, and we are going to see the tier method that is the multi-resolution. I'm going to add the multi-resolution modifier, and what this modifier does is let me subdivide this mesh and sculpt it in different levels of detail. So I am in the tier level of detail, I can sculpt, but we can also go back to the second level and continue manipulating this mesh. And it is going to preserve the details along all the levels of detail. I can go back to the tier level and the detail will be preserved. Let's make some creases around here. I will increase the strength of the crease and make something like this. And now I will go back to the first level of detail, to the first subdivision, and move everything. And when I go back to the tier level, all these details are going to be preserved. So at this point, we can define the workflows. Which one of these workflows is more viable for different situations? Well, normally in the sculpting, you begin with a blocking, creating the shapes with very low details, and then gradually we are going to add the details. To begin, we can start with the Dintopo. I'm going to remove this multi-resolution. We can create our shapes with Dintopo, and it is going to create new geometry, updating the mesh, always. All the things I do are going to create new geometry. So with this method, you don't need to worry for the geometry, only for the shape and the sculpting. So this is one of the options to start sculpting, mostly for the first steps of the sculpting, because at some point the dynamic topology could also be very slow. We can also use the remesh. We can create our shapes and from time to time use the Ctrl-R shortcut to remesh your sculpting. Ctrl-R, modify the shape, Ctrl-R again, and it is going to be updating the mesh. But it's important that you only use one of these two methods. I personally prefer to use mostly the remesh because I feel it is faster. Remember that these two methods are not compatible between them, so we can't use Dintopo after using the remesh. It can fail in the calculations. Sometimes it don't work, or the remesh can remove the details created in the Dintopo. So in my case, I use the remesh to create all the blocking for the sculpting. And the multi-resolution in general is used when you already have some model defined and you want to add more levels of detail. Here in this other file we have an example for the multi-res. As I said, the multi-res is very useful when we already have some geometry created. In this case, I took this character when it has all the shapes created and I added the multi-red to add more levels of detail. For example, for these wrinkles, I use the multi-res, because I can create very sharp edges with it. But the thing with the multi-res is that you need a very fluid topology of quads. So if we see it in edit mode, we can see that we have a very clean geometry that is completely in quads. In consequence, when we subdivide it, it is going to preserve a polished surface. So if we have any triangle or a topology of quads that is not fluid, this surface is going to get damaged when we add the multi-resolution modifier. So to work with multi-resolution, we need a very clean topology with a fluid topology of quads or make a manual retopology. In this case, I did a bit of both. So as I said, this is basically to add the last layers of detail. So we should not take this kind of geometry, these voxel remeshed geometries, and use them with the multi-resolution modifier. Technically we can do it, but when we subdivide it, we are going to have this kind of artifacts in the surface, because the mesh is not fluid. This mesh is completely in quads, but it is not very fluid, and we are going to have these deformations. In some areas we are not going to be able to polish because of the topology. So to use the multi-res, we need a manual retopology or make a quad remesh that gives us as a result a very fluid mesh of quads. At this point, Blender has a quad remesh tool that tries to create a fluid topology of quads, but it is a tool that still needs some work in the development. So we already saw all the available methods in Blender, and along the course we are going to be applying them, and we are going to see which one of these tools is more viable for different situations.